Hello everyone, this is Yufeng, and in this video I'm going to introduce how I modify the Project Zero, the NBody simulation, to make it look nicer. So what I've done to the program is that first of all I've changed the 2D simulation into the 3-dimensional simulation. So basically I've added another dimension to it. So now we have position x, y, and z, and also velocity x and y and z. And also I've changed how the planets are generated. So before it was extracted from basically a static image, but now I've modified it so that it can use program to dynamically generate the mesh of the planet. So basically a mesh of sphere. Also, I've added the 3-dimensional projection algorithm into the program so that it actually looks like 3D. So an object will appear bigger when in front of the camera and appears smaller when it's far away. So let's look at how I've modded the configuration file, because we now have an actual dimension and don't need the image, so we need to modify the configuration file. So on the above, the planets.txt file, it's the original configuration file. And now below, first of all, I've added the position z and velocity z for the 3D motion. And also I've added the radius of each planet so that the program can dynamically generate the sphere. Since we no longer need the image file, I've changed the image file name into just the name of the planet. And so the text can be drawn onto the simulation screen. And because we have a new file format, I've decided to add a kind of like a version number as the first number in the configuration file. So before the original file, this number represents how many planets are in the file, which is a positive number. So I've decided the version of this new file format should be -1. So if the old program reads the new file format, it will raise arrow because number of planets shouldn't be negative. And if my new program reads the old configuration file, it will recognize that the first number isn't -1, and so we are entering the wrong config file. So this version number acts kind of like a protection to the program. Yeah. And now, also I've added all the planets in the solar system to the simulation, and these data of the planets are from Wikipedia and also from this website, which is amazing. It tells us how the radius and orbital velocity of each planet compared to Earth. And now let's see the simulation in action. Here, you'll notice that the sun is white, and it's kind of small. No worry, we can now press the bracket key on the keyboard to increase or to move closer to the sun. And now you can see that the sun is comprised of a mesh with many vertices. Yeah, so this is how the code dynamically generates a sphere. And also you can see other planets are orbiting the sun. This is Mercury and Venus, and if we go further, we can see Mars and Earth, and further Jupiter, Saturn, Uranus, and Neptune. So these are all the planets. And with such a scale, you can like really feel how the huge of scale the universe, the solar system has. Like, it's really amazing. But now in this scale, we cannot actually see how these smaller planets are moving. But don't worry, we can now press the number 2 on the keyboard to change the view. And now we can change from the side view to the top-down view. So we can see clear how the planets are moving. Like, they're all moving in circular motion. Yeah, and also you can see the sun in another perspective. And by pressing number 1, we can change the mode back. And also notice how Jupiter appears bigger than the sun because of the 3D projection. Because now Jupiter is closer to the camera than the sun, so it appears bigger. And when it moves back to the sun, it will appear smaller again. Yeah. So this is how the simulation looks like with 3-dimensional, with 3D projection, and also with programmatically generated planets or spheres. Okay, so now how did I know how to generate the sphere with code? Actually, I didn't, but I learned it from this website, the OpenGL Sphere. OpenGL is a 3D rendering engine, and in this article, it tells me how OpenGL prefers to generate a mesh of the sphere. So a mesh is composed of different vertices, and each vertex, which is a dot, has its own position. So what I've done in the code is that I take the original position of the planet, which is the original position X, Y, and Z, and add it with the position of the vertex to get the position of the vertex in the world. And after I have all the position information of each vertex, I also generate a list of indices, which tells me in which order should I draw the vertex. And then I draw all the vertices. So now we have different spheres. Then I use the code in this website. It tells how to use WebGL, another 3D rendering engine based on web page, and it is actually written in JavaScript. So I've modified the code here. Basically, take the projection matrix and multiply the projection matrix with the vertex position we have from the previous step. And now we have a new vector with components X, Y, and Z. So actually the resulting vector, the X and Y, tells us where should the vertex be on the screen. So this is how 3D projection basically works. It takes the vertex from a 3D space and project it onto the 2D space of the screen. And so that appears 3D to us, the viewers. Yeah, and that's basically how my code and my modification works. And I think that's all. Yeah, thank you. Bye bye.